Let us begin again to solve numerical problems in physics, but not this time on engineering mechanics. I know you have been liking my engineering mechanics videos and have been watching it seriously for a few days. I'll do that a little later. So I hope by now you have watched the previous videos on Pulley systems where I have explained and derived the expression for acceleration and tension, and have explained you different shortcuts to write the answer quickly, especially in the expression for acceleration in a pulley system, how to write it quickly. I have explained in previous videos. Now, this one is taken from a book called Concepts of Physics by Professor HCVerma from IIT Kanpur. And you can expect this kind of problems if you are preparing for your JEE main entrance examination in India or medical entrance examination in India. And in fact, the problem is important in different board examinations in India and also abroad. Now look at the diagram. Now, normally in my previous videos, I have taken this mass as m1 and this as m2, and I have derived the equations accordingly. But since it is in the book, this is given as m1 and this is given as m2, so I have kept it as such. I have not modified. I have not taken this as m1 and this as m2, which I normally do. I take the mass on the right hand side as m1 and one on the left hand side as m2. But this is given as m1, this is given as m2, so I have not changed it. Now look, this surface is smooth. There is a mass m1 here. The value is not known. It might be given in in a real life numerical problem, the value may be given. This mass is m2, and here the surface is smooth. Means as this m1 tries to slide either to left or right, there is no opposing force between the surfaces in contact. Now, and this string which is connected to m1 here and connected to m2 here is passing over a pulley, right? And the string is also light, that is, its mass will not be considered, and there is no friction here also. And now what extra is given, there is a F here applied on m1 to the left hand side, and its value is given as m2g over 2. Means whatever is the weight of this body, this F is equal to half of that. F is equal to half of that. Now the weight of this mass m2 will be vertically downward. Let me show it here. So this will be your m2 times g. And if this m2 is falling down, which I don't know whether this will fall down or this will go up, that depends on the net force. So if this is falling down, the tension on this mass m2 will be to this side, away from it. And why the tension is away from the mass, I have already explained in previous videos. Let me explain you once more here. Now I take a string like this. Look at this is a string. Can you push an object with this string? No. Suppose this is the object. Can you push it? You cannot push it. You cannot push this object, this scale, with this string. But if you tie this string around it, and you can definitely pull it. Pull it. So therefore the tension is always away from the mass. So for this mass m2, the tension is away, and this is the same string, and the same tension for this mass is away from it. Let it be T. Now, without writing the equation for this and equation for this, you can straightway write the expression for acceleration, which I have explained in previous videos also. Now, this is m1, this is same thing as this m1. And this is M2, same thing as this is M2, this M2, and here this F, I saw it here, and this value of F is given in the numerical problem as M2 times G over 2, means half of its weight. And if you consider this M2 horizontal like this, then this M2G is this much, M2G, and this string is shown here, the tension. Now this is an internal force, so I don't consider this. To write the expression for acceleration quickly, that is the shortcut. If you look at this system comprising of two masses M1 and M2 acted upon by two different forces, M2G to this side and F to this side, and the value of F is equal to M2G over 2. Since M2G is more than M2G over 2, so this system will move towards right. That is same thing as saying this mass M2 will fall down with some acceleration because there is a net force. Now, so since we know F is equal to M times A, so your acceleration is equal to F over M. Now let me put it in a different way. So your acceleration will be, the net force on this system is M2G minus M2G over 2. M2G minus M2G over 2, that is the net force. Now the net mass is equal to M1 plus M2. So I rewrite here, the denominator is M1 plus M2. If you take LCM, you get 2 here, 2 times M2G minus M2 times G. So 2 times M2G minus M2G is equal to M2 times G over 2 whole over M1 plus M2. So this goes to the numerator. So this becomes M2 over 2 times M1 plus M2 times G. So let me write it in a different way. A is equal to M2 over 2 times M1 plus M2 whole into G. I have kept the mass separately and the acceleration separately. Now this is acceleration, so the right hand side we must be acceleration. Look, this is acceleration, this is mass, its unit is kilogram. Kilogram plus kilogram is kilogram, kg cancels. So left is equal to right, dimensional is correct. Now if you want to write the equations and derive the same acceleration, you can do it. So for that you have to write the equation for M2 and the equation for M1. So what will be the equation for M2? Since this is coming down, M2G will be more than T, then only it will come down with acceleration, because this is a force, this is a force, this minus this is a net force downward, and any force is equal to mass times acceleration. Therefore, for this mass, the equation will be M2 times G minus T is the net force on this, so that will be its mass times acceleration, equation 1. Then if you come back here, T is to this side and that is being opposed, and this mass M1 is moving to the right hand side because M2 is falling down. So for mass M1 I write T minus of F is a net force on M1, so that will be M1 times equation number 2. And I have told you before, whenever in a pulley system there will be two masses, you will have two equations. If you add them properly, you will get the expression for acceleration. T cancels. So M2 times G minus F, this plus this, taking A common, I am left within bracket as M1 plus M2, and the value of F is given in the numerical, as m2g over 2. So I write here m2g over 2 is equal to 8 times m1 plus m2. You take LCM here, this becomes 2m2g minus m2g. That is equal to m2g over 2 is equal to 8 times m1 plus m2. m1 plus m2 is multiplied here, bring it to the left hand side, so it will be divided. So let me rewrite it here. So your acceleration becomes m2 over 2 times m1 plus m2 whole into g. That is same thing as we derived it here by using the method of shortcuts. Now to find the tension, you have to find the tension, there is no shortcut. You have to put this value of A either in equation 1 or in equation 2. Either in equation 1 or in equation 2. So let me put it here and find the tension. So let me put it here in the second equation, that is T minus of F is equal to m1 times A. So T is equal to F comes to this side, becomes positive, plus m1 times A, and F is given as m2 g over 2 plus m1 times A. A we calculated here, m2 over 2 times m1 plus m2 times g. Now you have to simplify this. So you need basic algebra only. So m2g over 2 plus m1 comes here, m1 m2 over 2 times m1 plus m2 times g. Look, there is a term g here, there is a term g here, both are added. So if you take g common, so this is m2 over 2 plus m1 m2 over 2 times m1 plus m2 whole into g is your tension. And if you want to simplify it, you can do so. Very simple. So your LCM becomes LCM of this and LCM of this becomes 2 times m1 plus m2. This divided by 2, I am left with this. So m2 will be multiplied with this, m1 plus m2, plus this divided by this is 1. So 1 times this is equal to m1 m2, this whole into g. So let us see, what do we get? m1 m2 plus m2 into m2 square plus m1 m2 2 times m1 plus m2 whole into g. Here is m1 m2, here is m1 m2. So 2 m1 m2 plus m2 square over 2 times m1 plus m2 whole into g is your value of tension. In the numerical, it was not, we are not asked to find the value of tension, but I just found it for you. Now, so that is all about. Thank you.